Hello, geometry students. This is Mr. Ellis, and today we're going to look at my first geometry video lesson, and this is going to be on skill number 5, use trigonometry to find unknown sides of a right triangle. So according to what I heard from you guys, this is the one that you need the most instruction on. So let's see what we have. We're going to find a missing side of a right triangle. So first thing is that this only applies to right triangles. And we have some skills for right triangles. Remember, to find the unknown side of a right triangle, I could use something I already know, the Pythagorean theorem. Now, the Pythagorean theorem says a squared plus b squared equals c squared. So if I know two sides, I can find the third one. But that's not what we're going to do today. We're going to learn how to use trigonometric ratios. So that's another way I can find a missing side of a right triangle. Maybe I don't know two sides, but maybe I do know an angle. So that's kind of where I'm at right now. So I would like to just say that we did some work to see why it works. But any triangle with a 22-degree angle is going to have the same ratio of sides. And that ratio is contained in my calculator. It's called the sine, 22. Sine of 22 is a ratio. Now, I can look at some triangles with a 22-degree angle, like this is one of them. And if I look at the sides, I say this ratio 3/8 is going to be the same as this ratio that also has a 22-degree angle of 6/16. Because these are similar triangles. They have angle, they're similar. These ratios are going to be the same. So it doesn't matter where I get that ratio. But if I didn't know, say, what 6 was, I could use that ratio to find that missing side. So that's our idea. We use the ratios of a triangle to find the missing sides. So here we have how we're going to set this up. So we're going to look at the trigonometric ratios of a triangle. So we have a known angle, we call that the reference angle, and we're going to look at the different sides. We have to give them names. So if this is my reference angle, it's actually kind of aiming at the opposite side. So if this is sort of like a loudspeaker, that's going to or a projector, it's going to project onto this side. That's known as the opposite side. And we're going to call it the opposite leg to be specific, because that is a leg of the triangle, so not to be confused. This one here is the hypotenuse, because it's opposite the right angle. So remember, the hypotenuse would always be found opposite the right angle. And the third one is called the adjacent leg, because it is a leg and it's next to, or it actually touches this angle here. So it's adjacent to this. It's a leg. It's not the hypotenuse. So there's my trigonometric ratios. Well, that's not my trigonometric ratios, but I'm just thinking over here. I've got the trigonometric ratios in my hand, but basically they're the ratios of any of these sides. So just pick two of them, like this side, the opposite leg, and the hypotenuse. That's a specific ratio. It's called the sine ratio. And we use this. Sine is opposite over hypotenuse. And if we wanted to find the adjacent in the hypotenuse ratio, that's called the cosine. And the one that we did in class before the shutdown was the tangent ratio. And the tangent ratio is the ratio of the two legs, the opposite and the adjacent. Now, these are written in a specific way so that we can remember them. Remember, this is the sine is opposite over hypotenuse. So S equals O over H shortened up. And that actually is kind of spelling a word, so. And the cosine equals the adjacent hypotenuse ratio. So adjacent over hypotenuse. And the tangent equals the opposite over the adjacent. And so this is where we get our mnemonic device to remember these three ratios. This one is SOH in that order. This one is CAH in that order. And this one is TOA in that order. So we have SOH-CAH-TOA. Now this is going to be the way we always remember how to set these functions up. Okay, so example one, let's suppose we're building a ramp, up to something, and we want to make this a specific length. So let's make this like 16 feet. And we want to find out how high up this would be. So let's just put an X there. So we know the angle is going to be 22, and this hypotenuse is going to be 16 feet. So this is how you do this. And I'm just going to give you the steps here. Somehow, some people, the steps are important. So I'll just put them over here, the steps. And these steps are written in a song. So if you pay attention and watch close, I'll be posting that song very soon. And in it is a prize for a scavenger hunt. We'll figure out how to do that. But here we go. The first step, from the lyrics of the song, from the reference angle, label all the sides. The opposite, adjacent, and hypotenuse are the three sides we're going to label. The reference angle is the known angle. So that's the first thing I'm going to do. So here I have the 22-degree angle. It's kind of shining on X. So this is the opposite. I'm just going to use the abbreviation OPP. And then across from the right angle, we have the hypotenuse. And then this one is the adjacent. Now, we don't actually use the adjacent here because the opposite is what we're trying to find, and the hypotenuse is what we know. So those are the two that I use. So the next step, after I label all the sides, I'm going to choose from the SOH-CAH-TOA menu. So then you got to choose from the SOH-CAH-TOA menu. So which one of these did I get in this particular case? So I'm just going to say this is an O and this is an H. So that only has to do with this one. So just by knowing those two letters, I fill it in. That's so. So now I write the equation. So the next step is to write the equation. So I have the sine, that's S, and don't forget to put in your reference angle. The sine of 22 equals the opposite over hypotenuse in that order. So the opposite is X, the hypotenuse is 16. Okay, now we have to do the last step, which is solve the equation. So that's basically it. So I'm going to look at this and say, how do I solve this equation? Well, remember, this could be thought of as a proportion. I could cross multiply, or I could think about multiplying both sides by 16. That's what you normally see. I'm just going to do it that way. Multiply 16, and that's going to get X by itself because that's going to cancel out the 16s. And over here I have 16 sine 22. So I'm going to say that X equals this thing right here, 16 times the sine of 22. And that's it. I have to put that in my calculator now. So when you do this, make sure you hit the DRG button, make sure you're in degrees. And I'm going to do 16 times the sine of 22. Calculator knows that that means sine when I just put it next to it, but sine 22, so I usually just take that shortcut. 16 sine 22 is the same as 16 times sine 22. I hit enter, that's 5.993. So X is approximately 5.99 to 3 significant digits. Now I'm going to put my units in feet. Hey, that reminds me, it looked like that other triangle that I did. Oh yeah, I knew the 16 and I was solving for this side. And I found out that's 5.99. Not 6, but this was measured and that's the exact. So if this is exactly 22, then this is going to be really close to 5.99, which is really basically close to 6. Here. Okay, now this example is important because this could relate to our flagpole problem. Like we had a flagpole. Let's suppose this is a flagpole. And that's a flag. Maybe it's the American flag. And now we want to figure out how tall the flagpole is. So one thing we can measure is a shadow. So we'll call this the shadow. And suppose we measure the shadow is 15 feet. And now we can't directly measure the flagpole maybe, but maybe we can measure this angle. Now this is called the angle of elevation, and I think that that's an important piece of vocabulary, so I'm going to put it over here. The angle of elevation, when you're looking straight out, along a horizontal, if you have an angle of elevation, that's how the angle that you're looking up at something. The angle of depression refers to looking down at something, like suppose you're on top of a mountain looking down at Mammoth Lakes or the high school or something. That's the angle of depression. So in this case, if you're standing at the end of the shadow, this would be the angle of elevation. So that is maybe what we measure. In this case, we're going to try to find the height of the flagpole. I'm going to use h for the height of the flagpole. And now we're going to solve this. So my steps are, label all the sides. So this is shining over here. So this right here is the opposite of the angle. The opposite one does not touch the angle, but the adjacent one does. This is the adjacent. And this is the hypotenuse, opposite the right angle. So now I'm going to choose from the SOH-CAH-TOA menu. Using opposite adjacent, that's O and A. O and A. So what goes with O and A from SOH-CAH-TOA? Oh, that's TOA. So we know that the tangent of my reference angle, 60 degrees, equals the opposite over the adjacent, which happens to be h divided by 15. Okay, that's it. So we just set it up and we do it. So we multiply both sides by 15, which is basically the same as cross multiplying. So some people just like to do the cross multiplying thing like this. Okay, yeah. And we have h times 1 is h equals 15 times the tangent of 60. And so we enter that into the calculator. So we have 15 tangent 60 is 25.98. So we're going to round that off to about 26 feet, 26.0. So h is approximately 26.0 feet. That's 3 significant digits. I have one more triangle here, and this one is here. So let's suppose that we want to find the hypotenuse x. Suppose this is a roof, and where we go, oh, I know this distance right here is 10 feet, and I want to find out how much this is, so I figure how much roofing material I would need there, maybe. Anyway, so the steps are, from the reference angle, here's the reference angle, looking out across here, this is the opposite, this is the hypotenuse, this is the adjacent leg, and then I choose the hypotenuse because that's what I need to find, and the adjacent because that's what I know. So those two letters are A and H. And what goes with A and H? C, to make CAH. So now I have cosine of 55 equals the adjacent over the hypotenuse, 10 divided by x. Okay, so this is it. I put that over 1 if I want to. I cross multiply, or I could multiply both sides by x to get that, but I'm noticing that x gets times the cosine of 55, and 1 times 10 equals 10. So x is still not solved for, so I'm going to have to divide both sides by the cosine of 55 in order to get x by itself. That cancels. So x equals 10 divided by the cosine of 55. Like, that would be 10 divided by the cosine of 55, just like that, into the calculator. So I have 10 divided by the cosine of 55, and that should give me the answer. So I get 17.43 to 3 significant digits. X is approximately 17.4 feet.